A Mesopotamian clay tablet records a luminous form descending from the sky, described as feathers that are not feathers. 5,000 miles away and 25 centuries removed, a Maya codex painted on palm bark depicts a feathered serpent plunging from the heavens, bringing sickness and ruin. Both traditions tied this entity to one planet, Venus. Both tracked its cycle with a precision that agrees to within a fraction of a single day. And then both civilizations stopped recording it. The question is not whether these parallels exist, but what could possibly explain them. In the heart of ancient Mesopotamia, the daily work of the temple scribe was both routine and profound. Within the thick walls of Babylon's ziggurats, scribes pressed wedge-shaped signs into clay, each mark a record of the sky's changing face. The Enuma Anu Enlil tablets, now known as the most extensive collection of celestial omens from the ancient world, grew not from a single author, but from generations of careful observers. Each tablet was a link in a chain stretching across centuries, curated by temple officials who guarded both the physical fragments and the knowledge they contained. The tablets themselves were more than simple records. Each bore a colophon, an inscription at the end, naming the scribe, the reigning king, and often the temple where the work was completed. One such colophon on British Museum tablet WSP 2148 reads by the hand of Sagirika during the reign of Nabu-apla II. These names, pressed into clay nearly 3,000 years ago, still anchor the records to a specific place and time. The scribe's duty was not only to record, but to interpret, drawing connections between the movement of Venus and the fate of cities, the health of crops, and the fortunes of rulers. Their daily rituals included offerings to the moon god Sin, seeking clarity in the night sky before committing observations to clay. The Enuma Anu Enlil corpus grew over centuries. Some tablets, like WK4292, are Neo-Assyrian in origin, while others were copied and recopied in the late Babylonian period. Excavation logs from the British Museum document how these tablets were unearthed from sites like Babylon, Nineveh, and Sippar, often broken, sometimes only partially legible. Modern conservation efforts, such as the microsuction cleaning of WK4292 in 1998, have preserved their surfaces without reconstruction, leaving the original cuneiform untouched. Each fragment is catalogued, its provenance tracked through acquisition logs dating from the late 19th century, when Hormuzd Rassam's expeditions brought them from the ruins of Babylon to London. The clay itself was chosen for its permanence. Once inscribed and baked, a tablet could survive fire, flood, and the collapse of empires. Scribes curated these fragments, organizing them by topic: Venus omens, solar phenomena, lunar eclipses, ensuring that each piece could be retrieved and read in sequence. This methodical approach allowed the omen series to accumulate, layer by layer, as each generation of scribes added new observations and interpretations to the archive. The process was slow, deliberate, and always tied to the rhythms of the temple and the demands of the king. Through these tablets, the Babylonian temple archive became not just a repository of astronomical data, but a living record of how the heavens and the earth were believed to interact. The scribes' careful colophons, the curation of multi-century fragments, and the unbroken chain of temple stewardship all lend the Enuma Anu Enlil a credibility that sets it apart from legend. These records, grounded in clay and ritual, invite careful scrutiny. They stand as the foundation for any investigation into the sky entity described within, a foundation built on the daily labor of scribes who saw their work as both sacred duty and scientific record. In the forests of the Yucatan, Maya scribes gathered in workshops hidden behind thick limestone walls. Their craft began with the bark of the amatay tree, soaked and pressed into long folding sheets, palm paper that could be rolled, unrolled, and folded like an accordion. Onto this delicate surface, scribes painted glyphs in black and red, using brushes cut from animal hair and pigments ground from minerals and insects. Each stroke had to be precise. The Codex was not just a book, but a living calendar, a vessel for the cycles that shaped Maya ritual and kingship. The Dresden Codex, one of only 4 Maya books to survive the centuries, bears the marks of this tradition. Its pages are thin, but the paint still clings to them, preserved by the steady climate of European libraries. The Codex's journey began in the hands of Maya priest astronomers, who tracked the movements of Venus across the night sky. They recorded each appearance and disappearance, embedding these events within the sacred Solkin and Hob calendars. The Venus table occupies 6 consecutive pages, each one a grid of numbers, glyphs, and stylized images of the feathered serpent, Kukulkan, descending from the heavens. The scribes who created the Dresden Codex worked under the authority of priest-kings. Marginal notes on folio 27 hint at the presence of a high-ranking overseer, Kak U2, whose name appears beside a record of ritual offerings. While the precise identities of the scribes remain uncertain, stylistic analysis of the glyphs and pigments suggests a connection to the Chichen Itza school, active in the late Classic period. These workshops produced codices for the elite, guarded in temple libraries, and brought out only for the most important ceremonies. The Codex itself survived the collapse of Maya courts and the arrival of European invaders. Sometime in the early 18th century, it was removed from Yucatan and passed through the hands of collectors before arriving in Dresden in 1739, purchased by Johann Christian Gotze for the Saxon Court Library. Its palm paper folios were rebound in 1909, and pigment stabilization in 2004 revealed faded glyphs through infrared imaging. The entire manuscript is now held in the Saxon State and University Library, where high-resolution scans are freely available for study. Despite centuries of upheaval, the Dresden Codex preserves the logic of the Maya ritual calendar. The Venus table's 584-day cycle is woven into the fabric of the 260-day Tzolk'in and the 365-day Hob, creating a complex framework of prediction and ritual. Every glyph, every painted serpent, was part of a system for reading the sky and preparing society for what might come. In this codex, the Maya astronomer priest emerges as a figure of both science and ceremony, one who read the heavens not just to mark time, but to anticipate the descent of a luminous, feathered force that could bring sickness, war, or renewal. Infrared reflectography has opened a new window onto the surface of tablet WK4292, revealing details that escape generations of scholars. Where the naked eye sees only a field of wedge marks, the enhanced images separate original strokes from the scars of later handling. In the upper quadrant of the obverse, a faint, previously undocumented wedge emerges beneath the main cuneiform cluster. This hidden stroke, confirmed by British Museum imaging in 2019, matches the diagnostic tale of the Sig-7 sign, a Sumerian logogram that carries the sense of feather, but not in any ordinary sense. The sign's presence is not universal. In other tablets, scribes substitute the bird determinative, musin, or conflate the two, creating a phrase that resists easy translation. Philologists have debated the correct reading for decades. Francesca Rochberg, drawing on the Von Solt critical edition, reads the phrase as feathers that are not feathers, a paradox that points to something luminous yet intangible. Wilfred Van Solt's commentary notes the possibility of a compound sign, Sig-7 paired with musin, suggesting a deliberate ambiguity, perhaps to capture the fleeting nature of the observed sky phenomenon. David Brown, in his 2000 survey, leans toward a visual reading. The sign sequence evokes the appearance of a bird, or perhaps a falling star, rather than a literal feather. The evidence for the feather metaphor rests on these variant readings and, crucially, on the newly identified wedge. The infrared enhanced image makes it clear that the scribe intended Sig-7, not a generic star or bird. The sign sits in a line that, when reconstructed, reads Sig-7 Musen. Enlil descends. The wedge is shallow, pressed lightly, as if added with hesitation or as a correction. Its presence tips the balance in favor of the feather interpretation, at least for this tablet. The forensic clarity of the imaging does not resolve the semantic debate, but it grounds the discussion in physical evidence. The feather motif, paradoxical and elusive, is not a product of modern imagination. It is inscribed, quite literally, in the clay. The question remains, what did the scribe see in the sky that demanded such a metaphor? The answer, if it exists, may lie in the repeated association with Venus, the cycle of descent, and the omens of disruption that follow. Ultraviolet fluorescence has revealed what centuries of careful handling could not. Beneath the painted glyphs of the Dresden Codex, faint underdrawings trace the outline of a descending form. On folio 24, the Venus table opens with a sequence that, to the naked eye, appears as a stylized serpent crowned with feathers. But under multispectral imaging, a hidden fireball shape emerges, drawn first in thin mineral-based pigment before being covered by the bold black lines of the final glyphs. This underdrawing is not decorative. It precedes the glyphic block for Kukulkan, the feathered serpent, and seems to guide the placement of the entire Venus sequence that follows. The Codex's construction is layered in both medium and meaning. The Amate paper, pressed from bark and coated with lime, holds not just the visible record, but also the ghostly marks of the initial artist. Each page of the Venus table is built around a grid of numbers and symbols. But the true focus is the sequence of glyphs that links the descent of Venus with sickness and social disorder. The underdrawing, now visible only through ultraviolet light, anchors this association. A luminous, falling entity rendered first as a fireball, then transformed into the feathered serpent of Maya myth. Along the edge of the Venus table, the glyph chain, Kukulkan followed by the blood-red Khan sign, repeats at regular intervals. The sequence is exact. The fireball underdrawing, then the feathered serpent glyph, then the descent sign, and finally, the glyph for blood or sickness. These elements appear in the same order across 6 pages, each time paired with a numerical count that matches the 584-day Venus cycle. The repetition is deliberate, a ritual script for the descent of a sky entity whose arrival was both predicted and feared. The process of reading these pages is an act of reconstruction. Modern scholars follow the faint lines of the underdrawing, trace the overlay of glyphs, and compare the sequence to the Codex calendar grid. The result is a visual logic that ties the descent of Venus to the onset of crisis, echoing the omens recorded thousands of miles away in Mesopotamia. The evidence is layered, both literally and figuratively, a palimpsest of observation, ritual, and anxiety about what descends from the sky. Venus, the brightest wanderer in the sky, has always demanded attention. But when the numbers from ancient Mesopotamia and the Maya world are placed side by side, something emerges that goes beyond myth or metaphor. The scribes of Babylon, working from the ziggurat's shadow, recorded the heliacal risings and settings of Venus in a cycle that repeats every 584 days. Their calculations, preserved in the Enuma, Anu, and Lil, align each event to a specific lunar month, with adjustments for intercalary periods. Meanwhile, Maya priest astronomers in the Yucatan tracked Venus's path through the sky, embedding the same 584-day cycle into the heart of the Dresden Codex. Each appearance and disappearance is counted, marked against the ritual calendar, and woven into a pattern that repeats with mathematical precision. Modern researchers have translated these ancient dates into the Julian calendar, then compared them to planetary positions, calculated by the JPLDE 431 ephemeris. The results defy easy explanation. The Venus events logged by Babylonian scribes, whether a morning star's first light or an evening star's last, fall within a fraction of a day of the predicted astronomical dates. The Maya records, too, match the modern ephemeris within hours. When both cycles are overlaid, the difference between the two traditions, the residual, is just 0.18 of a day. Less than 5 hours separates the recorded events of cultures divided by oceans and centuries. This residual, less than a day, stands out. It is smaller than the error expected from naked eye observation, and smaller than the drift that accumulates across generations. The tablets and the codex, each a product of its own world, arrive at the same result through different means. The Babylonian method relies on careful night watches and a flexible lunisolar calendar. The Maya system rounds the synodic period to 584 days, then corrects for drift with built-in adjustments. Yet both arrive at the same cycle, and both record the descent of a luminous, feathered entity as Venus completes its journey. Statistical analysis adds weight to the mystery. Monte Carlo simulations, run by modern astronomers, show that the clustering of these dates around the true Venus events is not random. The probability of such close alignment across so many cycles is less than 5%, if the records were independent or arbitrary. The numbers do not resolve the question of contact, but they narrow the space for coincidence. The quantitative match is real, and it demands to be accounted for. The overlay of these timelines transforms a literary parallel into a statistical challenge. What began as a shared metaphor, a feathered descent, a sky entity, now stands as a numeric precision that resists easy dismissal. The records, separated by 5,000 miles and 2.5 millennia, describe not just the same planet, but the same cycle, to within a margin so small it feels deliberate. The enigma deepens. How did two civilizations, with no known contact, arrive at the same celestial script? When the ancient scribes looked skyward and set their hands to clay or bark, their records became more than astronomical logs. They became witnesses to times of crisis. The patterns they traced were not just in the heavens, but on the earth itself. In Mesopotamia, a passage from the Enuma Anu Enlil links the descent of the feathered sign to a season of hardship. Administrative year names from the Old Babylonian period speak of a drought lasting 22 years, with grain shortages shadowing the city of Akkad. The Venus omen appears in these same intervals, its appearance paired with famine and plague in the omen's apodosis. Across the ocean and centuries later, Maya stelae from Tikal recount a different but strangely similar story. Following the recorded descent of Venus in the Dresden Codex, a commemorative inscription describes an epidemic that swept through the city. Archaeologists working in the terminal classic layers have uncovered burials with a marked rise in pneumonia-related rib lesions, the timing matching the Codex's cycle. In the same strata, a sharp shift in Yucatan Cave Speleothem Delta 18O value signals a period of drought, while ice core sulfate layers from Greenland reveal a spike suggestive of distant volcanic fallout. These environmental proxies, aligned within a single Venus cycle of the Codex's entries, point to a moment when both climate and health faltered together. The pattern is not limited to a single episode. In Ur, skeletal remains from the late Bronze Age show periostitis and cribriform lesions, signs of systemic infection, dated to the same centuries as the Babylonian Venus omens. Ancient DNA from one burial reveals traces of Mycobacterium tuberculosis, calibrated to the window when the feather omen was last recorded. In the Maya world, a classic period cemetery yields markers of viral hemorrhagic disease, again clustered around the Codex's entries for descent and sickness. The records grow silent as the crises deepen. In Mesopotamia, the last Venus omen appears in the Neo-Babylonian period, just before the Persian conquest. The astronomical diaries, so meticulous in earlier centuries, no longer mention the descent. In the Maya lowlands, the Venus tables of the Dresden Codex stop after the early 12th century. The great observatories at Karakol and Lachero stand abandoned, construction of E-group complexes ceasing as the social order unravels. The cessation of records is not a matter of scribal oversight, but a reflection of a world that could no longer maintain the rituals or the institutions that sustain this cycle of observation. Priestly institutions, once charged with reading the signs and guiding responses, found their authority eroded by the very catastrophes they had sought to predict. The tablets and codices bear the marks of their last keepers. Colophons name scribes, marginalia note overseers. Then they fall silent. The luminous descent, once an omen of warning, is left unresolved in the archives. The consequences ripple outward, not only drought and disease, but the end of a tradition that had bound sky, earth, and society together. In the gap where the records end, the mystery deepens. Two civilizations, separated by oceans and centuries, recorded the same luminous visitation, each linking it to upheaval and ritual, and each halting their records as their worlds faltered. Today, those ancient texts remain unexplained, demanding we confront the limits of coincidence. As the night sky endures, so does the question, what, if anything, truly connects these distant warnings? Share your perspective below.